In this video, I want to cover dividing rational expressions. Okay, so if you remember from our last video, we mentioned the rule. If we have the square root of a divided by b, this is equal to the square root of a divided by the square root of b if we assume that a and b are both positive, they're both greater than 0. Okay, so we're going to take advantage of that, at least at the start here, and do a few examples. We're going to see if we can simplify these as much as we can. So here we have the square root of 2 divided by the square root of 72. Okay, well, neither of these are immediately reducible to whole numbers, so we are going to have to use this rule. So we can rewrite this using this rule as the square root of 2 divided by 72. Okay, or we can rewrite this, if we reduce that, this will end up becoming the square root of 1 divided by 36. 72 divided by 2 is 36. So we'll have the square root of 1 over 36, but these are both perfect squares. So now we can put this back into our original form as the square root of 1 over the square root of 36. Okay, the square root of 1 is just 1, and the square root of 36 is 6. So our answer is going to be 1 over 6. Okay, they don't always simplify perfectly, but you can make them look a little nicer. So how about this one? Here we have the square root of 66 divided by the square root of 6. This is going to give us the square root of 66 over 6, which is just the square root of 11, and that's as simple as you're going to make that one, right? So the square root of 11 is the simplest way we could write this. Okay, square root of 50 divided by the square root of 2. Well, you could write out the square root of 50 as square root of 2 times 50, and then the square root of 2 times the square root of 50, divide out the square root, or 25, and then we could divide out the square root of 2. But there's a faster way to do this. We could just rewrite this as the square root of 50 divided by 2, which is the square root of 25, which is just 5. Okay? So sometimes utilizing this rule actually makes your life quite a bit easier. Okay, so other things we need to consider when dividing. Usually we like to get rid of radicals in the denominator when at all possible. That makes our lives a lot easier when we're dealing with more complicated equations and expressions that we want to simplify. So we have to do something called rationalizing, okay? That means to rewrite a fraction without a radical in the denominator. So if you have a fraction, the square root of a over the square root of b, hopefully we would agree that the square root of a over the square root of b is equal to the square root of a over the square root of b times the square root of b over the square root of b. Okay? Because all we're doing here is multiplying by 1. The square root of b over itself is just 1. Anything over itself is 1. So we don't actually change anything. We just creatively rewrite that. And then we can utilize our rules here. So we have the square root of a times b over the square root of b squared, which just gives us the square root of a times b over b. Okay, so the square root of a over the square root of b is equal to the square root of a times b over b. All right, so let's solve a few problems that way. So here we have the square root of 3 over 2. So this is equal to the square root of 3 over the square root of 2. Okay, and then we can write this as the square root of 3 over the square root of 2 times the square root of 2 over the square root of 2. Okay, so from here, we can rewrite this as the square root of 3 times 2 over the square root of 2 times the square root of 2, which is just 2. So we end up with the square root of 6 over 2. Okay? Or if you memorize that formula, you can also just use that, right? You could start right away, and you could have the square root of, if this is a, this is b, we could have the square root of 3 times 2 over b, which is 2, okay? Which is just the square root of 6 over 2, okay? So if we apply that one here, we have the square root of 2 over 10. The first thing we always want to do, by the way, is we want to try and simplify this as much as we can before we utilize this rule, okay? So if we If we see something like this, we want to rewrite this as the square root of 1 over 5. 2 over 10 simplifies to 1 over 5. And then we can just go ahead and apply our rule. Okay, so we first need to get it into the square root of 1 over the square root of 5. Okay, and then we can rewrite this as the square root of a times b, which will be 1 times 5 over b, which is 5. And so we end up with the square root of 5 over 5. Okay, here we have the square root of 6 over 14. So that's the same thing as the square root of 6 over the square root of 14. Actually, let's back up. We can simplify this. Okay, we can simplify this quite a bit. So this becomes, okay, 6 over 14 we can write as the square root of 3 over 7. And then we have the square root of 3 over the square root of 7. And now we can use our rule, and we can get the square root of a times b. So the square root of 3 times 7 over b, which is 7. And we get the square root of 21 over 7. Okay? And sometimes you may want to use conjugates in order to simplify a denominator. Okay? So if you remember from our previous section, we were able to use, well, from our previous video, we were able to use, are you able to use conjugates to try and simplify, sorry. We saw conjugates in the previous video, and what we noticed from that is that we were able to get very nice results out of multiplying by a conjugate, right? Because you square effectively everything, so therefore it makes all of these square roots go away. Okay, so what we're able to do here is we're able to utilize that property to make our lives easier for rationalizing an expression. So here we have negative 7 over 3 times the square root of 2 plus 1. Okay, so what we can do is we can rewrite this as negative 7 over 3 times the square root of 2 plus 1 times 3 times the square root of 2 minus 1 over 3 times the square root of 2 minus 1. And again, we're dividing something by itself, so this is equal to 1. We don't change the value of anything here. All we're doing is multiplying by 1 in a creative way. Okay, but this has the nice property of having a conjugate with the denominator, right? So if we multiply 3 times the square root of 2 plus 1 times 3 times the square root of 2 minus 1, we're multiplying by a conjugate, and all of the square roots should disappear. Okay, so but we can simplify first. So let's do the numerators. Okay, so if we have negative 7 times 3 times the square root of 2 minus, or this will just become plus 7. So we have negative 7 times negative 1 gives us plus 7. Okay, and then in the denominator, we're going to have, remember, if we have a plus b times a minus b, this is equal to a squared minus b squared. We will end up with 3 times the square root of 2 squared minus 1 squared. Okay, so in the numerator, we can pull out a 7. So we have 7 times negative 3 times the square root of 2 plus 1. And then here, we'll end up with 9 times 2 minus 1, which is going to be equal to 7 times negative 3 times the square root of 2 plus 1. I wrote this wrong. 7 times negative 3 times the square root of 2 plus 1 over 18 minus 1, which is just 17. Okay? And let's take a look at one more. Take a look at one more. Here we have 9 over 3 times the square root of 3 minus 2. Okay, so if we rewrite this in terms of conjugates, we'll have negative 9 over 3 times the square root of 3 minus 2 times 3 times the square root of 3 plus 2 over 3 times the square root of 3 plus 2. What we're doing here is we're multiplying by the conjugate of the denominator over itself, okay? So here, we can go ahead and simplify the numerator. If we have negative 9 times 3 times the square root of 3, that's going to give us negative 27 times the square root of 3, and we'll have minus 18. And then if we notice that this is A and this is B, we have conjugates here, so this becomes 3 times the square root of 3 squared minus 2 squared. And we'll end up with negative 27 times the square root of 3, negative 27 times the square root of 3 minus 18 over, looks like we have, let's see, 9 times 3 minus 4, which is going to give us negative 27 times the square root of 3 minus 18 times 27 minus 4, which is going to give us negative 27 times the square root of, if I can't write today, negative 27 times the square root of 3 minus 18 over 23. Okay? And then you can factor out a 9 here if you'd like. So we'll get 9 times negative 3 times the square root of 3 minus 2 over 23 for your final answer.